Okay, next up on our card stock is center. So we're going through all of the things we have to describe when we're asked to talk about a distribution. We've talked about shape, we've talked about outliers. Now we're moving on to center. The reason why we're so interested in the center of the distribution is because it describes a typical observation. So center is related to the mean. I think we're all kind of comfortable with the idea of what a mean is. It's the average of a data set. So when we get an average, let's say that our average quiz score, our last quiz, the average was 85. What that means is that most kids were around 85. There were probably some kids that were higher, some kids that were lower, but overall where we ended up was around an 85. That's what an average is. It gives you a pretty decent picture of a data set, and it tells you what a typical observation would be. So I could say something like, students typically scored about 85 on our last quiz. So center describes a typical observation in a data set, which is helpful, especially when you have a huge data set. If we're talking about 200 or 300 observations, even 50 observations, instead of having to look at all 50 of those observations, it might be nice to look at just the center to know what a typical observation was. So like I have more than 50 AP Stats students, maybe I don't want to have to go in and look at every single kid's score. I could instead say, well, on the quiz, a typical student earned about an 85. And that would give a pretty good indication of my data set. That says a lot about where my students are at and what their understanding is without having to look at every single data value that I collected. So center is our best descriptor of what a typical observation looks like. And there are two things that we can use to measure center. One of them we've been working on quite a bit, and that is the median. The median is the observation in the data set such that half of the data is below it and half of the data is above it. And hopefully that sounds very familiar to you because we have discussed that several times. Now, there's a disadvantage to using the median, and the disadvantage is that it's a location. It is only one value. So the median is a location. It is describing...
Cheyenne, please come to the main office.
So annoying. So annoying. I can barely even handle it. The median is describing one value in the data set. Now, it still describes the typical observation. We can use the median to say kids typically scored 85, but we have to be really clear on the fact that the median is or comes from a location in the data set, and we're speaking specifically about one value, and it is the value for which half of the data is to the left and half of the data is to the right. So it is helpful. It does give us good information. We just have to be aware that it is based off of a location and it is one value in the data set. Now, that is different than the mean, because to calculate the mean or the average, we add all of the data values. That is the biggest difference, and I'm going to highlight that. In order to calculate the mean, we add all of the observations. We add all of the data values in our data set. And then we divide by the total number of observations. So the mean is a best case scenario situation because it gives us information about all of the data values. So just to recap, median is a measure of center. Mean is also a measure of center. Median is describing one value in the data set, and mean takes into consideration all of the values in the data set. But here's where things get a little bit tricky. You have to decide which one is the best description of center. So median is one value, mean considers all of the values, and you have to decide which one is the best. Now, hopefully some of you guys are thinking, well, if the mean takes into consideration all of the data values, then wouldn't the mean be the best description of center? So let's flip our page and let's look at the situations in which mean would be a great description of center. So I want you to notice how I have grouped these two, or these sets of graphs. These guys belong in one group, these guys belong in the other. Let's maybe take a moment to see if we can decide why are these together and these ones are not. Take a moment to see if you can decide. So these four groups or graphs are grouped together because there is no skew. There is no skew in these graphs. So these are grouped together because there is no skew. And these are grouped together because they are skewed. Well, why does that matter? Well, it turns out if a data set is not skewed, the mean and the median will equal each other. If a data set is not skewed, the mean and the median will equal each other. However, if the data is skewed, your mean and median will not equal. So mean, I would say, is the best case scenario, but you can only use it when there's no skew. If there's skew in your data set, you have to use the median for your center. Use median for center. Now, let's not forget, center is important because it tells us about a typical observation in our data set, or the typical observation. You don't want to use mean when you have a skewed data set because your mean is going to be affected by the skew. So I'm going to go through an example of why this is. So I have a data set here that is just the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe I'll write this on a separate sheet just to keep these separate for now. So I have a data set 1, 2, 3, 4, 5, 6, 7, 8. Did I go 9? 9. This data set is not skewed. In fact, it's uniform. There's no peak. If we put this on a dot plot, it would just be 9 dots. So there's no skew here. If we found the median, we would go 1, 2, 3, 4, 1, 2, 3, 4. So that means 5 is our median. If we calculate the average, so average or the mean is denoted by X bar. We add up all these numbers. We get 45. We divide it by the number of observations, which is 9, and we get 5. So this is a symmetric data set with no skew. And notice what we determined here is true. The mean and the median are equal because there's no skew. So no skew in this data set. The mean is 5, the median is 5. Now let's skew this data set. Instead of my biggest value being 9, I'm changing it to 50. So now this data set is skewed right. This data set is now skewed right because I added a data value that is very far to the right and significantly farther away from the data value before it. So I calculate the median and notice it is exactly the same. It is still 5. But if I recalculate the mean, instead of it being 5, it is now 9.6. So let's talk about what this means. In this data value, the typical observation is 5. There are some values below it and some values above it, but typically our observations are around 5. Our average is also 5. There is no skew here. Here, most of our data values are around 5. Most of our data values are still around 5. We have some below, some above, but still most of them are around 5. Except for this one outlier all the way on the far right-hand side that is making our distribution skewed. And notice now our mean goes from 5 all the way up to almost twice that, all the way up to almost 10. So what this is trying to illustrate to you is two things. Number one, if you have a skewed data set, you're either going to have values that are really high on the right-hand side or really low on the left-hand side. When you add those data values in to calculate the mean, what ends up happening is it drags the mean toward the skew. So what that means is if your data is right skewed, meaning it is the larger values, it drags your mean up toward the right. So notice that's what happened. We had 5 and now it's further right at 10. So if you have a skewed data set, it's going to drag your mean to the skew. Well, then the other thing we need to note is that does not represent our data very well, because just like here, most of our data is still around 5. But because of this one guy, our average makes it look like most of our data is around 10. When none of our data values are 10, we have 8 and then we have a 50. So in this case, when you have skew, mean is no longer a good description of a typical value because of the outliers pulling the mean toward the skew. So hopefully we can see that now on these. Most of our data values are probably from about 80 to 140. But we have a skew here where we have from 40 to 80, we have a few values dragging toward the left. So that means that if we use the mean, it's going to be lower than a typical observation. It's going to be lower than the median because this skew is dragging that typical observation off toward the left where the skew is at. So this is why we use median, because median's going to be about right here. And notice, that is closer to where most of the data is. That is closer to where most of your data is. Whereas the mean might be all the way out here because these observations are dragging it toward the left. So median would be here and mean would be here. Well, notice how the median is closer to where most of the data is. The mean is not close to where most of the data is. So that is why we need to use the median for center or for describing the typical observation if there is skew. It's the same for this guy. If you have a lot of large values, if you're skewed or have an outlier to the right, that's going to drag your mean also to the right. It's going to make it so that your mean is greater than the median. So in this case, your median is probably right about here, and your mean is probably here. Well, notice that your median is close to where the rest of the data set is, but your mean is not. Your mean is not as close to the rest of the data. I'm going to erase this one because these don't line up. But like on this one, they do. This is the median and this is the mean, so that is a good visual. But on this one, they're opposite, so I erased it. Or you could leave it in and just make sure that you label them. Make sure that you label that this one was the median and that this one was the mean. So the biggest takeaway from what I have just been discussing is that if you have a skewed data set or if you have outliers, those values are going to drag your mean in the same direction. It's like a magnet. It's going to drag the mean so that it's farther away from where the rest of the data is, or it's farther away from the typical values. So if there is no skew, you use the mean, because the mean takes into consideration all of the data values, and that is better. But if there is skew, you don't want to use the mean because the mean is being pulled toward the skew or being pulled toward the outlier. So I'm going to highlight that. I'm going to highlight that in this case, I want to use the median for center. And then I'm going to flip back on this side, and I'm going to write a note to myself on the mean bullet point that the mean is better, but affected by skew and outliers. The mean is better, but affected by skew or outliers. So because of that, you can't always use it. The median, you can always describe the typical observation with your median. You can always describe a typical observation with your median. The advantage to the mean is that it takes into consideration all of the data values. The disadvantage is if you have unusually large or small data values, it is going to distort your typical observation, or I should really say it's going to distort your mean so that it doesn't reflect the typical observation anymore. Okay, so that is all of the information on center. I know that that is a ton of information, which is why I have decided to split these different things out into separate videos, because it's so much at once, but so important that you understand all of the details to each little section that they're asking you about. So one more. It's not quite as much as center, so just one more. Hang in there, guys.